cause of the emissions is mainly due to the transportation as well as the power generation. Here we can see the power generation, almost 13.13 billion tons of CO2 has been emitted in the year 2020, which is accounted for almost 37% of worldwide emissions. Here, the mainly we are going to get from the thermal power generations, where the coal is going to be used for the electricity production. Now, second, we can see the transportation sector. The transportation industry, it is going to generate almost 7.29 billion metric tons of CO2, which is the second largest in the carbon dioxide emitter. So this is one of the aspect to attract to go for an EV. This is also one of the aspect, that is the emissions of the carbon dioxide, which is going to cause for the global warming. So this amount of carbon dioxide levels from the transport sector, as well as the depletion of the fossil fuels, and we can see the deep increase in the crude oil prices, which all made it to go for an alternative for the transportation sector. Now, here we can see how the variation is going to be in the emissions. Coming to the power industry, we can see 13.13, which is the highest, and the transportation sector, which is the second one, 7.29, and in the case of buildings, which is 3.39, and industrial combustion 7.82, and other sectors 4.34. These are some of the how the analysis is going to be in the year 2020, the global emissions of CO2. Now, in the previously, what we are going to use for the transportation of the people and transportation of the commodities, we are going to use the IC engines, as well as due to its upgradation of the technology and the more oil exploration and industrial development, which has used the propulsion of the vehicles through the decades. As the population is going to increase day by day, as well as its economy rise, the transportation emissions are going to be at the high level. So there is a need to go for the quantification of the emissions at regular intervals, not to affect the control strategies. Otherwise, there is a huge problem we are going to face by the concept of what is global warming. If there is no prediction of the emissions, how it is going to be. So there is a need to quantify at regular intervals. Among these, the road transport, which is the second largest, where we can minimize the emissions, which is almost the half of the total greenhouse gas emissions. So here we can see how the sector-wise in the transportation system, how the emissions are being. Here we can see almost 78% of emissions are going to be we are going to get in the carbon dioxide emissions in the case of transportation sector. Here we can see how the variation is going to be from the passenger vehicles, the shipping, buses, the 2 or 3 wheelers, the heavy trucks, the aviation, the rail. Here we can see almost 78% is only from the road transport. So where there is a need to go for reduce the emissions. Almost 78% of emissions from the road transport. So this is one of the main aspects to attract the attention to go for an alternate mode of transport. So there is a need to go for electrification of the transportation sector, which has been attracted to this because of this high impact of the emissions. So due to this, again, the second aspect is the depletion of the fossil fuels. Due to the scarcity of the fossil fuels and the deep increase in the crude oil and the ecological destruction of the transportation sector, which all made the attention draw for the electrification of the transport sector. So this is the one of the viable choice to go for the alternate for the emission the road transport. So proportionately, there is an growth for the EVs in the upcoming years. So here EVs are going to become the low carbon replacement for traditional fossil fuels. So when we switch for this electrification of the transport sector, they can balance the supply demand imbalance in the case of oil. Now, what are the aspects we are going to consider when we go for the electrification of the transport sector? That is going to become a key point of our session. Now, just we have analyzed what is the need to go for electrification of the transport sector due to the existing of the EVs. We'll see what is its impact. First, before we go for the impact of EVs on distribution system, what is the sales penetration? How the EVs are going to be rise day by day? So here we can see that, one minute. Yeah, here we can see that how the penetrations is going to increase day by day. Here we can see the analysis of structure, how the overall electric vehicles has been increased. If you can see the global share of 8.3% in the year 2021 from 4.2, which is in the year 2020, which is going to have almost 6.75 millions of vehicles have been on the road. Here in the statistical analysis, what we have observed here is in the year 2021, there is a drastical increase in the penetration of the EVs, which is almost 0.32 million vehicles in India. The main objective of this is in order to achieve a net carbon emission by the year 2070. It should be a net zero carbon emission. Over the last 3 years, we can see the penetration is 0.52 millions of EVs were registered in India, according to the data given by the Ministry of Heavy Industries. Now, here the several states in India have been encouraging and formulated the EV policies in order to increase the usage of the EVs. The different policies and initiatives and promotions have been done by the different states over the India in order to encourage the EV penetration in India. So here we can see that as we go for the transportation, electrification of this transportation sector, in the case of roadways, here we can see the India's market has going to be entered into a new era of transportation system, as well as in the case of power generation system, that is the distribution system, how to balance with this rise of the increase of the penetration of the vehicles. So both is going to start with a new era, the usage of the EVs on the road, as well as uh, the mobility, e-mobility of the distribution system. Now here, the central government has been allotted for different sectors on the in order to increase for the e-mobility transition. Here, some of the sectors: Ministry of Road Transport and Highways, Department of Heavy Industry, Department of Industrial Policy and Promotions, Ministry of Finance, Ministry of Housing and Urban Affairs, Ministry of Power, Ministry of New and Renewable Energy, and Department of Science and Technology, and the NITI Aayog, the Planning Commission. These all are going to play a key role in order to have an awareness, in order to have different policies, all in all aspects, in order to increase the penetration of EVs in the India, in order to achieve the zero carbon emission by the year 2070. If you see the analysis here, we can see in the case of automobile industry, which the Indian automobile is the fifth largest in the world, which is going to be expected the third largest by the year 2030. So here the NITI Aayog aims to achieve 70% of commercial vehicles, 30% of the private vehicles, and 40% of the buses, and 80% of the 2 and 3 wheelers should be electrified by the year 2030. Whatever may be the vehicles which are going to be registered, almost this percent should be available to be electrified by the year 2030. Here we can see how the sales penetration of the three-wheelers are, we can see private cars and commercial cars, the buses, the two-wheelers. Here we can see the high is the three-wheelers, the analysis how it is going to increase, and prospective with this, the two-wheelers and all the cases. How the sales penetration is going to increase by the year 2030. Here we can see how the electric vehicles sales is going to be increased from variation in the year 2020 and 2021. Here we can observe that in the year 2021, there is a drastic increase in the sales penetration of EV when compared to the year of 2020. Due to that may be due to the increase in the awareness among the people, creating the providing the incentives and the policies, different policies have been implemented by the government of India in order to encourage. All these aspects are going to play a key role in order to increase the sales penetration of EVs. Here we can see in the year 2021, where we have observed having a high penetration of EVs, how it is going to be in the state-wise, among the state-wise distribution. Here we can observe that Uttar Pradesh is going to have the highest share of EV sales in the year 2021. The number of units sold is almost 66,704, having a high penetration of EVs, which is followed by the Karnataka state, which is around 33,302 units of EVs, and following with the Tamil Nadu, 30,036 units. Here, the Uttar Pradesh is, we can observe here how the penetration is going to be based on this two-wheeler, three-wheeler, and the buses. In the Uttar Pradesh, we can observe that in the UP state, the sales penetration is mainly dominated by the three-wheelers. While in the Karnataka and Maharashtra led to the two-wheeler segment and the four-wheeler segment respectively. Here we can see how the variation is going to be based on the usage of the two-wheeler, three-wheelers, and the buses, how the share is going to be proportionately increased from in the year 2021 or the state-wise. Here we can see the Telangana, we have high penetration of two-wheelers when compared to the three and the other vehicles, four-wheelers. Next, now till now we have observed how the sales penetration, what is the need to go for the EV. Now we will see how to estimate this EV load demand. We will have a brief case study which was done by the Electrical Power Survey. We'll have a brief discussion on that part, how to estimate the EV load demand. This is also going to play a key role so that to accommodate the additional energy which is to be given to the EV, there is a need to go for the prediction of this EV load demand, which is going to play a key role. Now here we can see that due to this rapid increase in the population, day by day, proportionately the EVs, the mobility is going to increase, proportionately the demand for the load is going to increase. So it is the demand on the grid is going to increase. So first, how to estimate this EV load demand? Here they have gone through for some of the assumptions before going for the analyzation of this EV load demand. First, they have shared some assumptions. Here we can see that the weighted average annual growth of vehicles sold for last 20 years has been calculated as 5%. And the same growth has been recommended for the future. So what they are going to consider is they are going to consider the 5% of growth in each and every year. That is one of the assumptions they have made. The second one is any vehicle which is sold is being registered it is going to be deregistered after 15 years. They are going to consider the lifespan of the vehicle only for the 15 years. And by the year 2030, only 30% of the total vehicle sales would be the electric vehicles. And by the year 2042, all the vehicle sales would be the BEVs, battery electric vehicles. So some of the assumptions they have made in order to estimate the load demand. The first one is the 5% of annual growth of the EVs. The second one is if the vehicle is used for 15 years, it is going to be deregistered after its use for 15 years. It is not going to be considered for the load demand estimation. And the 30% of total EV sales would be the EVs by the year 2030, and all the vehicle sales would be the EVs by the year 2040. And here we can see how we are going to consider the mobility of two and four wheelers. which is here, these are the parameters which are taken, the efficiency, the average kilometer travel in a year, what is the charging time, and the ratio of the vehicle which is charged over the night. This is the brief data what they have considered for the assumption case based on the previous statistical data. Next, what is the methodology to implement for the estimation of the load demand? So they have observed that they have considered there is estimation of 1.95 crores by the year 2021-22, including the EV sales. There is a total vehicle sales of 1.95 crores, both the IC as well as the EV. So in order to estimate for the future prediction, what is they are going to consider for the vehicle sale by the year 2029, 32, 29 and 30. Here we have seen that 5% of annual growth for each and every year with a rate of 1.95 crore vehicles, which was sold by the year 2021-22. Based on that data, they are going to analyze for 5% of annual growth for each and every year on average basis. So, and it is to be observed that only 30% of those would be the EV, the 21-22. First, the base value of the EVs sold has been assumed as a total number of registered EVs. So, what we are going to consider here is how many number of EVs sold will be assumed as total number of EVs registered by the year 21-22, which is around 10.5 lakhs. Based on the above assumptions, the CAGR indicates the cumulative annual growth rate for the EV sales has been calculated for the period of 21-22 to 29-30. For this 10 years, they are going to estimate the cumulative annual growth rate, which is going to be increased year by year. They are going to consider the cumulative growth. Based on this growth rate of CAGR, the year-wise EV sales has been estimated for the period from 21-22 to 29-30. Based on the above aspect. The similar approach has been, A similar approach has been adopted for calculating the EV sales for the year 2030, 31 to 41, 42. The same approach they are going to consider the penetration. Next, that the BEV sales for 2041 and 42 has been estimated as equal to the total vehicle sales as per assumption made. Which all the EVs, all the vehicle registered will be the EVs by 2041, 42. Here also the same aspect, the base value for the period has been considered as the estimated number of EVs sold during 29-30, which was mentioned in the second point. The same what we are concerned for 21-22 to 29-30. Again, based on the above assumptions, we have considered for the next 30 to 40, the cumulative annual growth rate. So what we are going to do here is we are going to estimate the cumulative annual growth rate from 21 to 30 and 31 to 40 based on the annual growth rate of 5% on each and every year, the cumulative growth, and 1.95 crores which was sold in the year 21-22. This was going to be taken as a reference. So based on this statistical data, how much amount of energy is going to be required, which is given by the formula, the total number of vehicles on road multiplied with efficiency of that particular vehicle, the two-wheeler or four-wheeler, and the average kilometers of travel over the year. So this will give the amount of what is the amount of energy required for the EV load demand, to estimate the EV load demand. Next, what is the peak demand? That is also very important fact to be considered, the peak demand. So that the peak demand, the grid is going to face a major challenge to withstand. So when we are going to expect the peak demand, what is the peak demand we can expect? It is given by the formula energy requirement in MU. MU indicates the million units we consider 1 kilowatt hour as 1 unit, if we consider, that is, MU indicates the million number of units, BU indicates billion number of units. Okay, here the energy requirement in million units into 1000 divided by the charging time into the year, 365 days. That formula will give what is the peak demand over the system. This is the methodology what the power survey have been considered in order to estimate the energy requirement for the only for the EV load demand, and what is the peak demand we can estimate over the system. So after estimating this energy requirement and peak demand, so based on the above assumptions made, they have observed that for the year 2031-32, the total BEV sales, the electric vehicle sales, are going to be 1.08 crores, and the total BEV on road will be 4.91 crores. And what is the energy requirement? The 27 BU. BU indicates the billion units of energy. And how much is the peak demand we are going to estimate? It's a 5 gigawatt. This is the peak demand we are going to estimate only for the EV. Based on the above statistical data and analysis, what they have taken with the methodology of estimating the load demand, these are the analysis they have observed. Once they estimate the load demand, next step is how to overcome this load demand. So there is some methodologies which have been adopted for all India energy requirement for states and discoms on account of EVs. First, what they are going to do is what is the additional energy requirement has been apportioned among various states in the ratio of number of vehicles registered in the year 2018-19. In a particular year, how much is the additional energy required for the particular year based on the number of vehicles registered. Secondly, they are going to segregate into two parts, domestic and commercial. What is the additional of energy requirement for domestic and commercial in the ratio of 70:30? And third, how they are going to distribute, how they are going to allot, how this additional energy requirement, how they are going to balance this additional energy requirement for the state among the various discoms. First, what they are going to estimate is the total energy requirement for domestic and commercial categories has been estimated. The ratio among the domestic and commercial categories based on the sales. The second one is how much amount of energy required over the state among the, it has been distributed to the discoms in the ratio of total energy requirement for domestic and the commercial cases. First, they will estimate the ratio of based on the registration of the vehicles, the domestic and commercial categories. Next, they will allot, they will distribute among the discoms for each state the respective ratio of energy requirement based on domestic and commercial categories. And finally, what is the final energy requirement over a particular discom has been distributed into the domestic and commercial categories in the ratio of 70:30 ratio. So this is the process how they are going to distribute the energy requirement, which is going to be energy peak demand from the EVs. This is the process how the central government, or we can say that in India, how they are going to allot. This is the what to say, the simple case study they are going to consider in order to allot the energy requirement over the states. Next, after estimating the load demand, next how to get this energy to the charging stations, how to charge the EV to their the charging stations. So we'll see how this electric vehicle charging infrastructure is going to be. Here with the standard protocol of Open Charge OCPI, Open Charge Point Interface Protocol, which is going to specify the charging station hierarchy, how the hierarchy level of charging station infrastructure is going to be. The first step is the location of the station, where the charging station has to locate. That we can say simply the optimal location of the EV charging station, which is going to play a key role in order to minimize the losses or in order to reduce the impact of the load on the distribution system. So the optimal location of the EV charging station is going to play a key role. Okay. Next, here we can see the different sectors like private locations, semi-public, and public locations. The private location is obviously the domestic residence where we can charge the vehicles in their own houses over the night. The semi-public stations locations here we can see in the case of this can be used over both the houses as well as in the case of parking lots, office place. In the case of malls where they park the vehicles, this will come under semi-public locations. The public locations is completely on the the outside of the road, the outside of the vehicles. The charging mainly we can see on the highways. And here we can see the battery swapping stations. The battery swapping stations is also one of the key aspect which is going to support this EV charging station infrastructure. The charging here we can see the more number of charging outlets on the especially on the highways in the upcoming futures. Okay, these are the three sectors: the private, semi-public, and public locations where we can see the charging stations, starting with our domestic houses, in the office, in the malls, in the case of highways, in all the aspects to increase the mobility of the e-vehicles. The second one is the electric vehicle supply equipment, that is the EVSC port. So here, first the one point I have to discuss mainly here is now let us compare with the existing combustion vehicles, where we can fuel the tank a maximum of 5 minutes for the full tank. It is obviously the 5 minutes, maximum of 5 minutes. But if we consider this port, so they will have the gun to pump the vehicle, the oil, petrol or diesel. Here we have the charging port, charging connector to say exactly. So here how many connectors? Say approximately we have 8 to 10 connectors, charging connectors in a EV charging station, approximately. Now compare with the existing EV petrol bunks where we are going to have the petrol or diesel. Compare with this analogy. Say we have 10 connectors for the charging station. How many vehicles it can accommodate for 10 connectors? Maximum of 10 vehicles it can accommodate. Then what about the rest of the vehicles? And also the main point here is the charging. What we are going to discuss: level 1, level 2, level 3 charging. Here, based on the anxiety of the end user, he will go for the levels of charging. So there is a waiting time for the 10 EVs to charge. Then what about the rest of the EVs? The queuing mechanism. This is all going to play a key role in the future. So in order to overcome on this one of the aspect, we have we is going to get a slot booking system. Slot booking system, there they can book the slot well before reaching the EV charging station, so that the slot will be the port connector will be available to charge their EV. That is a mobile slot booking system. Now here, this EVSC port indicates the number of connectors which are available over a particular charging station. Next, here we can see the levels of charging. Here we can see level 1, level 2, and level 3. Here level 1, we can say the domestic case, which is 120 volts and maximum 12 to 16 amperes, which is going to charge of 1.4 to 1.9 kilowatts, which is going to range for 3 to 5 hours, 3 to 5 miles per hour. The level 2, which is a semi-public, here we can see the 208 to 240 volts, having a range of current 12 to 80 amperes, with a maximum load charging of 19.2 kilowatts, where the range is of 10 to 20 miles per hour. The last one is the boost charging. We can say DC fast charging, which is having 480 volts at the three-phase supply, and which can offer current of 125 amperes, the load charge of 290 kilowatt. With this type of charging, almost 80% of the vehicles can be charged by 20 to 30 minutes. But what is the main drawback of this type of charging? That is the DC fast charging is the battery life, the battery degradation. If you go more times, here the level of charging, like level 1, level 2, level 3 charging, which can be made, that which depends upon the customer, that is the end user, what level of charging I need to go, based on its anxiety, that is based on its behavior, how much emergency it is. If you go for boost charging, it is going to affect two cases. First one is the battery of the EV. If you go for long run of only the boost charging or DC charging, the battery lifespan is going to affect. The second one at the same time is the grid is going to draw more amount of imbalance in the system. The grid is going to affect more imbalance when you go only for the fast charging. Both is going to have a main case. Okay. Next, the fourth one is the types of charging hardware. That indicates what is the pace at which the batteries are going to charge. Now here we can see that we have observed level 1, level 2, and level 3 charging. Here we can see we have observed the three types of charges, that is the onboard charging. We had three cases: onboard, offboard, and wireless charging. First is the onboard charging. Here we can see the conversion of the AC to DC. The conversion is going to take place in the vehicle itself. Such type of vehicle is said to be the onboard charging. Almost level 1 and level 2 will always go with the onboard charging. The third case of DC fast charging, we will go for the offboard charging. This is the second one, the offboard charging, where the conversion of the energy, the conversion of the supply is going to take place outside of the vehicle, which is going to be used only for the DC charging, that is the boost charging. And third one is the wireless charging. What is this wireless charging? What is what is its impact? Now, just now we had discussed regarding the EV charging station infrastructure. So it can accommodate only limited number of vehicles to charge with the help of the connector. So whatever the vehicles which are on the queuing, they can use this wireless charging. That is to be designed by the respective EV charging station, so that he can accommodate the more number of EVs to charge over a period of time. So this wireless charging is also playing a key role. This is also going to the wireless charging is also going to take place mainly in the malls. In the case of malls, also in the case of workplaces, where the vehicles can be over the parking over the lot.
దాంట్లోనేమో 4 ఉన్నాయి.
అంటే అప్డేట్ దాంట్లో మనం పంపించిన ఫైల్లో లేవు, కానీ ఎవరో దాన్ని కాపీ చేశారు.
ఇంపాక్ట్ ఆఫ్ వాట్ ఇస్ ద
దాంట్లో వర్డ్ డాక్యుమెంట్ నా దగ్గర ఉంది, మన లేటెస్ట్ మోడల్ కరెక్ట్.
హలో,
దాంట్లో 11 లేదు.
Yeah, I think so. Someone is.
Yes, sir. Someone has joined in.
Yeah. Okay. Good. Now, once we go for this EV charging station infrastructure with the optimal placement of EV charging station over a particular location. Next, what is impact of EVs on the grid? Here we can see the impact on what is the impact on its power grid, impact on the environment, and the impact on the economy. Coming to the impact on the pocket, we have both the positive as well as the negative impacts. First, we come to the negative impacts, where the EV load is going to become an additional load to the existing conventional load on the distribution system. So, what are the problems it is going to face? The instability, the increase in the peak demand, the harmonics, sag, the power loss, and the overloading of the transformers. These are all of the aspects which are going to impact due to this EV's mobility on the grid. So this all to be maintained in the balance in order to have the stability of the grid system. From the positive impact, we can facilitate through the smart grid and having the concept of vehicle to grid, which we'll discuss in the further topic, and the integration of the renewable energy sources. So we can facilitate with this aspect, positive impact. Next, environment. What is the main advantage is the emissions are going to be minimized. Come to the economy, obviously the low operating cost or maintenance cost. As we know, when we compare with the number of units consumed for full charge of the EV and for 1 liter of petrol or diesel, how much it is going to be. So we are going to have a lower operating cost. And also there's a chance to benefit from V2G. How to benefit in the point of economy from this V2G. That also we'll discuss in the upcoming slides. Okay. This is the brief impact how an EV mobility on the distribution system. Next, here we can see due to this, that is the outline what we have observed. Due to this increasing popularity of EVs, it is going to increase the number of charging stations. As the number of EVs are going to increase day by day, proportionately the charging stations, which is going to have a significant effect on the distribution grid. So there is a need to accommodate or to provide some additional energy in order to accommodate the additional load of an EV. The situation is going to be very concerned if it does not consider the charging during the rush hours, which is going to become an overload of the system. There's a probability of network damage. So there is a need to go for the concern while charging due to this impact to go for the additional energy to balance the additional EV load. So this large penetration of EVs is going to become a much challenges, such in the case of thermal constraints of the transmission lines due to overload, the voltage drop, what we have observed. And these are the uncertainty. And also we can see that the demand is not constant, which is going to be uneven. This is stochastic. We cannot estimate that, which we can make that as constant, which is going to be uneven. This is also one of the aspect how it is going to sustain. So the different charging strategies as well as the grid integration methods are to be developed in order to minimize these adverse effects of EV charging and also to strengthen the benefits of the EV grid integration. So there is the need to go for an alternate generation of the energy in order to overcome this additional EV load. Now, so if we go for, as we have discussed, if you go for fast charging technology, which is make it convenient for the user, vehicle owner comfort not to get his vehicle charged very quickly, but it is going to impose a lot of challenges in the smooth functioning of the distribution system. Further, if you charge large number of EVs simultaneously over the grid, will pose operational challenges due to the peak hours. If all the vehicles are going to charge at the same time, it is going to have a huge impact on the grid system and losses. So the explosive growth of these EVs and the increased demand of the energy, what is the need to go for this is either to upgrade the existing infrastructure to accommodate with coordinated charging, or to introduce the smart grid technologies to manage the EV charging through the real-time monitoring and control. These are two aspects what we can consider for the large penetration of the EVs. either to upgrade the existing infrastructure to accommodate the load, or to introduce the smart grid technologies based on the real-time monitoring and control. So what are these EV charging strategies to implement in order to withstand the grid stability of the system? We can see here we have 4 charging or discharging techniques what we are going to consider: uncontrolled charging or discharging, controlled smart charging, and indirectly controlled charging. These are the 4 techniques what we are going to consider, what we can see in the charging strategies. First, we go for the uncontrolled charging or discharging case. As the name itself indicates, uncontrolled. So what it means, simply the end user will go for the charging whenever the vehicle, whenever whenever he is observed there is a less SOC of the battery, he will just go to charge. That is a dumb charging. We can say as a dumb charging. So which will allow us to charge or discharge at rated power as soon as it is plugged in or to charge the battery. He will charge the battery until it equals the maximum SOC, state of charge. So irrespective of the scenario, just he will charge his vehicle whenever he observed having the less SOC. So thus the charging method is going to be inflexible for demand side management. So it is going to have having a large impact on the demand side management if you go for this uncontrolled charging technique. But it can provide comfort for the owners to make charging. They can make the decision freely when to charge. Irrespective over the 24/7, he can charge on any time. In the case of this uncontrolled charging, he can take his decision to make it charging. But however, this uncontrolled charging is going to have a negative impact on the local distribution system, having a demand supply imbalance, and on all aspects it is going to affect the distribution system. If you go for this dumb charging, it is uncontrolled charging or discharging. The second one is the controlled charging or discharging. Here comes the picture of system operators. Here the system operators are going to be having a freedom to decide when to charge and discharge. In the case of uncontrolled charging, the EV owner, that is the end user, have the freedom at what time to charge or discharge. Here, in the case of coordinate or controlled charging, the system operators have the freedom to guide when to charge or discharge the EV. So, but however, the EV owner has to depend on the system operator, the EV aggregators, to immediately charge the EV or discharge the EV, which is under the control. Here we can see in this figure what we can observe in the case of uncontrolled charging. Here directly it is going to charge the EV without the analysis or without any decision made by system operator. Here there is no involvement of EV aggregator in the uncontrolled charging. That is completely freedom given by the EV. It is the end user to charge his EV based on his available source. Coming to the control charging or discharging, here we can see the system operator, we can say EV aggregator. You can see the dotted line indicates the charging control, and the straight line on the black color indicates the power flow from the charging station. Here, the system operator will guide to charge, when to charge or when to discharge, based on the data, based on the real-time data available, so that he can charge or discharge to the charging station. Okay, here the EV aggregator is the key role to make it possible to charge and discharge, when to charge or discharge. Next, third comes the smart charging technique. The smart charging technique, here the management of the charging and discharging based on completely on real-time energy demand, the grid requirement, and the grid quality. Here we can see in the figure, we can observe that the system operator is there, included the AI technique, artificial intelligence technique, where here we can see how it is going to communicate the information to the power grid, the demand, and the renewable generation. On all these aspects, it is going to estimate the real-time analysis based on the prediction. So he will communicate with the end user or the EV user the peak time to charge or off-peak time to discharge. Based on his analysis, he will charge. So that on this aspect, both the end user as well as the distribution operator, system operator, both are going to be benefited. In the further, we can expect in the future, now we can see the tariff, we have a, based on the slab, in the future we can expect the tariff based on the number of hours, based on the hours. Each hour it may vary based on the demand. We can expect in the future, the further, when most of the EVs are going to be on the road. Based on this real-time monitoring and control of the demand. The last one is the indirectly controlled charging mechanism. So what is this indirectly controlled mechanism? Here we can see the concept of dynamic pricing. The dynamic pricing, such as the time of use and the real-time pricing, what we had discussed. The how the price of unit to charge or discharge is going to vary based on the peak load demand and the off-load demand. So they will suggest to go for the charging the EVs at the off-peak hours. That may be either in the workplace, that may be in the houses, or that may be on the various aspects of charging. And they can discharge during the peak hours. We'll see in the upcoming slides how they can benefit through this that mechanism of vehicle to grid. The incentive policies such as variable electricity tariffs to attract more EV owners to participate in the V2G system, so that he can charge the vehicle during the off-peak hours and he can discharge during the peak hours, so that there may be a variation in the unit price cost. Say approximately, for example, he is going to charge his EV in the off-fleet load with the 6 units of 6 rupees per unit, an approximate cost. So during the peak hours, there may be a dynamic change in the pricing of say 25 rupees or 30 rupees per discharge. So obviously he'll go to discharge based on his availability of SOC on the vehicle and his planning over the day. He can discharge, so that he can be benefited, both having a mutual benefit of the end user as well as the system operator, the system operator. Both will be benefited based on this dynamic pricing schemes. This we can expect in the future, having the dynamic pricing over each and every hour. Like directly we can get a if we go for a shopping mall, when we want to doing shopping or when we watch the movies, when we park in the vehicles in our parking lot where we have the charging stations, just we'll get an SMS like how we are going to get for the recharge, like the recharge of the mobile. The same way we are going to get an SMS like it is the peak hour or you want to discharge your EV. If you go for yes, then automatically it is going to discharge your EV. If you say no, then it is going to remain as it is. So these are the mechanisms what we can expect in the future in order to get the smooth functioning of the vehicle to grid technology. Next is the artificial intelligence based forecasting model. Now what is the key role of this artificial intelligence? Here what we are going to do here is based on the available statistical data, based on the conventional load, the EV load over the year, on the particular year, how to predict the total load demand over the upcoming years. Or in the say, that is one of the case. The other case is how to balance the system based on the demand. So these are three, here we can see the three critical components. What we are going to consider is related to forecasting, scheduling, and dynamic pricing. First, they will forecast, then schedule, and finally implement the dynamic pricing based on the demand. So the accurate forecasting is going to play a key role, which is going to become the key information, we can say the main aspect to schedule the further models, how the planning is going to be. So the accuracy for the forecasting is going to play a key role first. And the next is scheduling, which provide the optimal charging or discharging based on the pricing of the system. And finally, it is going to be a closed loop system. Like I will see we'll discuss on the figure which is in the upcoming slides. It is going to be a closed loop system. First, the forecasting, next scheduling, next dynamic pricing. It is going to be varying continuously based on the forecasting and the scheduling and the dynamic pricing. Here, what we can get is the accurate forecasting results are going to play a crucial role for making the optimal EV charging or discharging strategies. Here we can see a forecasting model through the AI techniques, the supervised learning. It is going to consider the historical data from the supply, historical data from the demand, and historical data from the system constraints, the miscellaneous system constraints. So based on this, it is going to forecast the prediction, and the information is going to be given to the scheduling. That is second case. Here, based on the reinforcement learning, that is the AI technique, it is going to schedule how much. Here we can see what is the real time available, what is the real time demand, the real time system constraints, which are the inputs given for the scheduling, and the charging and discharging. Based on these constraints, it is going to schedule based on the available forecast of EV, forecast of the load demand. It is going to schedule the off hours and peak hours, and it is going to have next is a dynamic pricing based on the load demand in order to balance the distribution system and also provide stability of the system. That next is dynamic pricing. Here again, it is going to be given to the forecasting model. It is going to be a closed loop system, which is going to be monitored, and which is going to be vary over the each and every hour, each and every minute also in the further. How based on the demand, how it is going to vary. Okay, this is one of the mechanism what we are going to use in the future for the dynamic pricing of the that is dynamic pricing of the units. Next, here is the impact. What is the impact of DG integration in the distribution system? First, what is the need to go for DG integration for distribution system? Now we have discussed the EV load demand, and it is when it is going to become the additional load for the existing conventional load, the total demand is going to be increasing, which is going to be very continuous. It is intermittent in nature. So in order to accommodate this additional EV load, there is a need to go for additional energy generation, which can be done by the distributed generators. So the only way to fulfill this rising energy demand is to increase the production and demand. If you go for transmission and distribution infrastructure, which is going to become costly and damaging the environment. So if I want to go for the additional energy generation, so it is going to become very costly and damaging the environment if you go for both transmission and distribution infrastructure. So the alternate way is to go for the production of power at the distribution level itself. That can be made easy by the DG, distributed generator. Here, the renewable sources, which are the natural sources available and are eco-friendly, which are an alternative for the fossil fuels, are going to be considered for the generation of energy at the distribution systems. But here also what we are going to observe, having the intermittent nature of the renewable sources like solar, wind, the biomass, whatever the cases, we have its intermittent nature, which is not continuous. The solar, obviously, we cannot generate the power of the night, and the wind velocity, based on the wind velocity, the wind power generation, on all aspects, we cannot get a continuous amount of energy from this, having a stochastic nature. So it will also become one of the causes. Next, also here, so there is a need to go for integration of the DG or the distribution system in order to overcome the additional load demand of EV. Now, these are one of the recommendations for the grid stabilization. The integration of both EV charging station and DC store distribution system. This is also one of the research point of view, which is going to have a key role, who are about to start their PhD to select their objectives. This is one of the factor. The integration of EV charging station and DC store distribution system concern the various factors. Various factors are going to be concerned. Here the existing load, here the EV load, and here the DG. Some of the DGs are going to be integrated to the system. Here we can see the bidirectional, which indicates the V2G also. Next, what is the now we have seen what is the impact of DG. Next, we go for what is the impact of V2G, vehicle to grid and distribution system. As we have observed that the stochastic nature of the DGs, distributed generators, as well as the EV load demand. If you go for the integration of DG alone in the distribution system to minimize the power loss or increase the voltage level to maintain the grid stability, which may not be up to the extent to improve the stability of the system. Why? Because both are not continuous, which are intermittent. So, based on the peak and offload demand, what we have discussed in the strategies, the vehicle to grid is going to play a key role with its bidirectional mode. Will supplement the system with a backup unit to provide the intermittency. So it is going to be have an additional backup. It is going to act as an additional DG to the system, where we can charge the battery during the off-peak hours and discharge during the peak hours. So here the proper planning of EVs to charge and discharge is going to play a key role for the effective utilization of the V2G. So here the V2G allows the EVs to utilize the onboard chargers, onboard batteries as an energy source for driving and energy storage systems for the power grids. Here, when we go for these renewable sources, when we have the excess power generation, we can charge to the batteries of the EV. So it is also going to act as one of the energy storage device. Therefore, utilizing the EV batteries with the fast charging and discharging via V2 technology can avoid the additional investment of the battery storage system. So here, what we can see here, observe here is based on if you go for the fast charging and discharging to the sources, it is going to affect. Here we can see some of the aspects of having the drawbacks of battery degradation. Some factors we will consider that also, how it is going to be. Here, what we can observe in this V2G technique is, if you consider the almost 70 to 80% of the people are going to be employees, which is going to park their vehicles in their offices or in the working places. So almost 90 to 95% of vehicles will be parked at that time, which is equivalent to almost total operating hours of the base load generators. So they can charge the EV based on their peak load and off-peak load demand. They can charge the EVs on the parking lots in the office hours, so that they can discharge during the peak demand of the grid. So this V2G is going to benefit both in the aspect of economic point of view, providing incentives to the end user, as well as for the stabilize, which is going to act as additional of the additional DG to the distribution system. Both are going to be benefited for the mechanism of this vehicle to grid. But the main thing is the awareness. The awareness is going to be playing a key role for the end user, either to charge or discharge, when to charge and when to discharge. This is going to play a key role. Now here we can see advantages, the additional what are advantages of this V2G? To avoid additional investment in a battery storage system. But because when we go for the vehicle to grid, based on the incentives, we can whatever the energy we have got for the storage of the energy, it is going to be free of cost, and enhance the renewable energy utilization, thus reducing the emissions. We can go for renewable energy utilization for charging the EVs. So if you consider solar, we can see the solar charging stations, the solar powered parking lots, where we can charge the EVs. The help of solar energy during the day hours. So they can use as a charging the batteries. Next, with the mobile energy storage with a fast reaction time, it is going to act as one of the mobile energy storage of the system, and provide the ancillary services for the power grids, and reduce the charging cost for the EV owners. These are all the one side of the advantages. Now come to disadvantage, the battery degradation. Here, if we increase the charge, if you use for charging and discharging very frequently, the cycles is going to increase. There's a degradation of the battery. This is one of the disadvantage of this part. The charging and discharging efficiency concerns. When we go for frequent charging and discharging, obviously the efficiency of the battery is also going to be a key role. An additional upfront investment if there is any maintenance of the battery. So these are the aspects what we can consider for disadvantage for the vehicle to grid technology. Next one, there is the last one, which is the smart charging framework. So when to charge and when to discharge and when to remain in the neutral case. That is based on, as we have observed that EVs are going to have an intermittent load demand. Based on this available SOC level, demand and power flow. Available SOC on the battery and the power load demand and the power flow. We have three categories. The first one is the neutral mode, where when the demand is greater than the power generation and the available SOC is less than the SOC minimum. The demand is high and the available SOC of the EV is less. In the case where the generation is greater than the demand and the available SOC is greater than the maximum, then there is no need to charge or discharge. So when the demand is high, if you charge, they are going to incur the more amount of tariff for charging. So it is better to avoid the charging. And when the generation is more than the demand and available SOC is more than the maximum, then there is no need to charge. And as the generation is high, there is no need to discharge. As already the generation is abundant, so there is no need to discharge. So this is here in this case, the EVs are going to remain in the neutral mode, ideal mode. There is no need to charge or discharge. Come to second case of charging mode. Here we can see when the generation is more than the demand and available SOC is less than the maximum SOC, then automatically it is observed as a off-peak demand, then where the vehicle can charge with a low or minimal price unit cost. It is suitable, it is suggested to go for the charging mode on that particular aspect. With all the indications are going to be given by system operator based on the AI load forecasting model what we have discussed. The third one is the discharging mode, where to discharge. Here we can say demand is greater than the generation and available SOC is greater than the SOC minimum, where the demand is high, that is the peak demand, and available SOC is greater than the SOC minimum. So I can charge, I can discharge based on the unit price of tariff, which is given by the system operator. So these are the three aspects, so that both the end user as well as the distribution system operator both will be benefited through this third case of analogy. So these are three possible cases which are going to be controlled by the EV system aggregator or distribution operator in order to control the imbalance of the system due to this additional EV load demand, which are going to play a key role. This we can see of what we had discussed in the case of a simple flow chart based on the check for the peak demand, if the generation is greater than demand, check for the condition, and go with the charging and neutral operation, the discharge, what we had discussed. Now, finally, what we are going to conclude with this session is on the aspect of this, what is the impact of this EV on the distribution system? The first is to go for the optimal location of EV charging station as well as optimal location of DGs before integrating to a distribution system, which is going to play a key role for demand and supply management. That's the first one. The second is due to this unpredictable nature, stochastic nature of EV demand and DGs on various charging patterns, the optimal scheduling is also going to play a key role for the effective operation of distribution system. And finally, due to this stochastic nature of the DGs, this V2G technique is also going to be an additional DG to provide to support the distribution system, which may improve the voltage profile for the stable and reliable operation of the distribution system. These are the key aspects what we are going to consider for the mobility of the for large mobility of the EVs over the road. What is its impact on the distribution system? Yeah. With this, I am going to conclude my session. If you have any queries, you are free to ask.
Thank you, Naresh sir.
Yeah, thank you, sir. If you have any queries, like if you are facing any problem,
Yes,
like
sir.
on what topic to choose for the research point of view, on
Participants.
this, you can ask the questions, no problem. To guide for the what is the objectives to be considered for the research point of view.
Thank you, sir. Thank you, sir.
Hello, sir.
Yes, madam, you can ask me.
Thank you, sir.
Hello, sir.
Yeah, madam. You can carry it.
Hello, sir. I am from Shakuntala from Bagalkot, sir.
Yeah.
Sir, what is the duration for the charging time of an electric vehicle, sir?
Can you come again, madam?
Hello, duration of the charging period, sir, for an electric vehicle.
Yeah. The charging duration depends upon the two aspects. Madam, first is what is the available charging on the vehicle? Which is for
Yes,
charging available SOC.
sir,
The second one
it
is,
depends upon a battery rating, no, sir?
yeah, obviously,
Which are you
battery,
are
how much
charging?
amount of SOC it is available. The second one is the level of charging you are going to consider.
Sound like the last lowest.
Level 3. These are two aspects what we can go for the what we can say how much time it is going to charge.
Okay, sir. Thank you, sir. Okay.
Yeah.
Thank you.
Yeah, any queries on this aspect, you can ask on this point.
Participants are requested to unmute yourself and ask the questions. Otherwise, you can post it in the chat box. We will address to this. Participants are requested to unmute yourself and ask the questions. Otherwise, you can post it in the chat box. We will address to this.
Hello, sir.
Yes, sir.
Yes.
Hello.
Yeah,
Myself Sachin. Myself Sachin from Pune. Sir, I just want to ask one question regarding research. Actually, I have applied for a PhD. So my research topic is in electric vehicles. So can you, sir, suggest any topic on which I can further do my research?
Yeah. Here, if we consider on the EV part, if we consider for the EV charging station, what we had discussed in the case of the EV aggregator, the EV system aggregator. Here we can see the aspects what we had discussed behind how to estimate the EV load demand based on the statistical data and through the AML, the artificial intelligence techniques, by using some load prediction models. And that is one of the aspects to predict the load demand, which is going to play a key role in the upcoming research point of view. But the main is the accurate result, which is a very important part. The second one is
Okay,
the location, the integration of the DG solar distribution system, and the simultaneous integration of EB and DG, how it is going to impact. and the integration of this B to G is going to impact. Considering all the different cases, we can do the analysis part for this research point of view.
Okay, sir. Thank you.
Hello, sir. Am I
Yes.
audible?
Yeah,
Am I audible, sir?
Yeah, audible.
Yes, sir. Thank you for your good session, sir. It is very informative. I have one query, sir.
Yeah,
This charging and discharging requires a bidirectional converter, sir.
yes, absolutely. Yes,
And
sir.
what will be the yes, sir? What will be the design criteria? What are the main key points that we need to consider while designing this bidirectional converter for charging? This is V to G, G to V.
Yeah.
Yes, sir. And you have touched upon that, but I could not get it
Yeah.
completely.
Yeah, actually, my research point of view is completely on the power system case.
Yes,
But
sir.
the question what you're asking, that is going to play a role on the power electronic side, the design of the converters.
Yes. But you did touched upon that, like when to charge, when to
That is going
discharge.
to be acted over there. Yeah, that is also your question is very good, sir. But the converters are going to play a key role for the fast moment of charging and discharging and to minimize the losses.
Yes.
On the point of view. That is also one of the key roles, sir, in a good aspect. But I cannot go in depth on the power electronic side. That is also one of the key aspects of it we can consider to minimize the losses for the movement of the energy.
Yes. Thank you, sir. If you can share your contact details so that I can be in touch with you in details.
Yeah, sure, sir.
Yeah.
And we have also heading the battery energy and electric vehicle lab in our campus BVIT in Asapur. Here, as we discussed in the introduction section, we have designed the e-cycles, e-bike, and an e-auto,
Okay,
and we are going to design the battery packs based on the load type of application of the load, and now we are concentrating on the e-cycle mobility of the system in the campus. That is one aspect, and the second one is the e-vehicle mobility in the campus. We are planning on this part. Presently, the research is we are going to do on that part.
Yes, sir.
Anyone
Thank you,
want
sir.
to visit and use the resources of our lab? You are always free to
Sure, sir.
welcome.
I am from Karnataka, sir.
Okay, yeah.
Yeah, and whenever time permits, certainly we will be in touch with you, and we would be very happy to visit your campus.
Yeah, sure, sir. Okay.
Yes.
Yeah, thank you, Sachin Jadhav, sir, and Dr. Basavaraj, sir. Yes, sir. There is one question in the chat box, sir.
Yes.
From Professor Vinuta. Sir, can you suggest what are present problems faced in distributed generation, sir?
Problems facing in distributed generators.
Yes, sir. What are present problems faced in DG?
DGs. Okay. Yeah. Yes. What are the problems in the first one is obviously the optimal location of the DG. Where to locate the DG in the distribution system? That is first of the main part. The second one is the stochastic nature, that is the uneven behavior of the DG, which is not continuous. So how to withstand the system during off-peak hours of the generation of the DG? So it is why, because DG is not continuous, how to withstand the remaining hours of energy. So we have to integrate with some of this mechanism to store the battery, or like some mechanisms we have to go. That is one of the second aspect. And when we go for the impact of this DG, now what are the constraints you are going to consider, like type 1 of injecting only the active power, type 2 injecting both reactive and active power, the type 3 both injecting active and reactive power, and taking the reactive power. These constraints, we can consider the different cases over there. What type of energy you are going to inject to the system. These are all the concerns what we can use for the research point of view for the various case studies.
Thank you.
Yes. Yes, sir. Any queries?
Sir, thank you, sir.
Yeah, thank you, thank you.
Sir, there is one more question posted in the chat box, sir. Can you please list out key issues in optimal placement of charging stations? Sir?
Key issues in optimal placement of charging station. The key issues is so obviously, what is the main main prospect of the charging station is way to locate the charging station is based on only on the, if you go for the distribution system, the strong buses, we are going to place the charging station on the strong buses. So to identify the weak and strong buses, and by using the various optimization techniques, and to locate the charging stations on the strong buses. That is one case. Here we can categorize in different cases. The second case is what is the what are the cases we can, what is the analogy we can get when we place the charging stations on the weak buses? What is its impact? The third one is considering both the cases. What is the result? What we are going to get when we consider both the weak and the strong buses? We can consider the different aspects. These are the issues what we can consider for the location of the charging station to analyze the losses or voltage profile in the distribution system.
Yes, sir. Thank you, sir.
Yes.
So what is SOC level, sir? There is a question from one of the audience, sir. What is SOC level? The question by Gaurav Kumar, sir.
Yeah, SOC indicates the state of charge. So how much amount of energy is available in the battery, so that how much amount of distance it can travel. So that indicates the SOC level of the battery. So I want to address one more point on this part, SOC. In our BEV lab, Battery Energy and Electric Vehicle Lab, we have a system known as EV emulator, electric vehicle emulator, where we can observe the performance curves of the SOC temperature, the cell voltage of the battery, all the aspects with the mobility of the EV. That's all we can observe in the system. Yeah.